Before we talked about the solving of triangles, if you still remember, guys, we referred to the solving of triangles whereby we were talking about a right-angled triangle, which was the basics of our solving triangles. We have a different condition, actually not that different from what we've been talking about from our normal right-angled triangle. No, it's not different, but we just have some additions that might happen to our right-angled triangle on our trigonometry. Based on the right-angled triangle, I explained before that if we are given a right-angled triangle, there are some specific considerations that we need to consider on our right-angled triangle, which are very, very important. Given a triangle referred to as ABC or whatever triangle that you be given, we talk of the application of the Pythagoras theorem, which is the basic part of our trigonometry that we need to understand. If we are given two different sides and also the hypotenuse, we understand that the hypotenuse squared is equal to side squared plus another side squared. That is the sum of the squares of the given shorter sides. Then we referred to an right-angled triangle again, this time given a certain angle referred to as theta, or this angle can be given any name. It can be theta, it can be alpha, it can be beta, like this. They are different notations, which are Greek notations that they use to represent an angle, just like A, B, C, D, E. They are letters. These are Greek alphabets that we talk about, the alpha, the beta, the theta. These are Greek alphabets that we are talking about. So in place of these letters that we are used to A, B, C, D, E, F, whatever, they are going to represent these angles in terms of the Greek alphabets. Let's say we are given this angle as alpha, or we are given this angle as theta, or we are given this angle as beta. It's just a normal presentation of the angle, which represents like 30 degrees or 40 degrees, whatever angle that you're given. All right, so given the angle theta in this case, this is the angle that is going to give us the information about the given sides that we have on our triangle. This triangle that we see here, it has the sides that are given. The only side that does not change is the hypotenuse. Like I said, this hypotenuse, the one that is opposite to 90 degrees, does not change. But these two other sides, they are referred according to the angle that you're given. The angle theta is the one that determines our sides. The one that faces theta is given as the opposite. And the one where the theta, the angle that you're given, and the 90 degrees are on the same side, these two angles, we say they are adjacent to each other. So it's referred to as the adjacent. So that's where we bring up the three basic trigonometrical ratios in our syllabus for our trigonometry for Zimsec. We work with three. That is, you are supposed to know from your SOHCAHTOA concept. All right, so we apply the SOHCAHTOA concept in this case, whereby we refer to the ratio of sine of the theta that we are given as the opposite over the hypotenuse. That's the sine of theta is going to be the opposite over the hypotenuse, in this case, the cosine of theta. So it's referred to as the cosine, but in short, we present it as cos, all right? So this is a sine from our side. So we show, in short, that is sine of theta. Cosine of theta, that is going to be cos of theta, being the adjacent over the hypotenuse. So there we are going to be referring to the adjacent over the hypotenuse. And we talk about the tan of theta in this case. All right, let me just present it here. We refer to the tan of theta being the opposite over the adjacent in this case. All right, so I refer to this basic introduction, if you still remember. And I said, what is important is for you to note according to the triangle. The most important part is from our triangle, this triangle that we have. All right, if we were to be given our theta, this side, these sides, they are going to change their positions. Meaning to say, this time our opposite is this one that is facing, the one that is direct facing to our theta. This is the one that is going to be our opposite. Where the theta and the 90 degrees are on the are sitting on the same side. They are sitting on the same side here. This one becomes the adjacent. These two angles, they are adjacent to each other. and this is our hypotenuse, the one that is always opposite to the 90 degrees, the one that is the longest side is our hypotenuse. So hypotenuse is just also a Greek name that simply means longest from the word longest. So that is where we take the word hypotenuse. All right. So if we are to consider this, I said we can use these trigonometrical ratios to find sides, to find angles. I'm not going to dwell into much of this because I talked about this one. We can be able to calculate the sides from the trigonometrical ratios. We can also be able to calculate the angles because this ratio, there's an angle, there are sides. So we can calculate the angle, we can calculate the sides. But on our Pythagoras theorem, we are only limited on sides. That is why here I never mentioned an angle to say this is theta or this is what. I just referred to sides. Here we are only dealing, or we are only working with the sides. All right, my case of this class is on the obtuse angle concept. This is the one that you guys have been asking. How do we consider, how do we work with the obtuse angle? This is the part of our syllabus. All right, we are also acquired to know the relationship that happens between the acute angle and the obtuse angle. In definition, if we know these angles, that is the most important part. All right, let me just have this part so that we will consider each other, we understand each other here. We have an acute angle and we have an obtuse angle. These are two different angles that we are supposed to know, acute angles. All right, an acute angle, given an acute angle, let's say we are referring to A as our acute angle. I'm going to talk this mathematically in terms of our inequalities. We are referring to an angle that is greater than 0 degrees. Can we have an angle that we say is equal to 0? It's impossible. It can be 0,1, it can be 0,2. So this acute angle is greater than 0 degrees, but less than 90 degrees. That is what we refer to as an acute. We are referring to all angles that are greater than 90 degrees, but these angles, they are less than, greater than 0 degrees, but less than 90. So we are talking about being greater than 0 degrees, but less than 90 degrees, but less than 90 degrees in this case. All right, we talk about the obtuse angle now, whereby I can just refer to this as O. So O representing the obtuse angle is an angle that must be greater than this time 90 degrees. Remember, at 90 degrees, we are referring to a right angle. If we are referring to 90 degrees, we are referring to a right angle. In this case, this is referred to as a right angle. So it must not be equal to 90. Once it's equal to 90, it's a right angle. So it must be greater than 90 degrees, but the same obtuse angle that we are referring, it must be less than 180 degrees. At 180 degrees, we are now referring to a straight line. At 180 degrees, we are now referring to a straight line. A straight line, that is where we obtain 180 degrees. So these are the two angles that I want to mention, especially in our syllabus. They consider mostly this obtuse angle. They want us to know what is the relationship between the obtuse angle and the acute angle. That is the whole part that you need to understand. All right, you'll be wondering on paper one, whereby you'll be given a triangle like this. They give you an angle of 120 degrees. They give you this side as 3 centimeters. They give you this side as 4. Let us just say 4,7, or let us just say 5 centimeters. In this case, you are given this side as 5 centimeters. They ask you to calculate the value of x. You wonder, you are in paper one, how am I going to calculate x? Because I need to find maybe it's cos of 120, or it's sine of 120, or it's tan of 120. But on the information, they will give you the value for sine 60 degrees. They will give you the value for cos 60 degrees. They will give you the value for tan 60 degrees. Then you are wondering, how am I going to use these values whilst I'm given an angle of 90 degrees? So this is the class that is going to answer our questions of this particular nature. All right, this is the part that we are going to focus. We said we've got an acute angle, then we've got a presentation of the obtuse angle in this case. If we are to relate this properly, we are going to see that these two, they share something in common. What is it that they share in common? They are both on a straight line. both on a straight line. Remember, a straight line, we are referring to what? Angles adding up to 180. So what am I trying to say if I'm saying both are on a straight line? It means these two angles, they add up to 180. If this is my acute angle here, and this is my obtuse angle here, these two, they must add up to 180 degrees, because remember, we are starting from 0 to 180. So meaning to say, if I have an acute angle, I must know its corresponding obtuse. All right, how can I explain this that you understand? If I am given an angle, let's say 50 degrees, it's an acute angle. It's in between this range from 0 to 90, in between, not 0, not 90, but in between. This is an acute angle. I must know its corresponding obtuse angle. If this being my acute angle, I must know its corresponding obtuse angle. And what is its corresponding angle? They are on a straight line, these two angles. So I know that on a straight line, these angles must add up to 180. So I'm going to simply subtract 180 minus 50 degrees. The moment I subtract the 50 degrees, this one from 180 from the straight line, I am obtaining the remaining angle, which is my obtuse angle. So this is the obtuse angle that is related to the angle of 50 degrees as an acute angle. So the best part that is, you are supposed to know the relationship before we talk about how are they related, the relationship alone about an obtuse angle and an acute angle, just the relationship. They are both on a straight line. So meaning to say, if I add these two angles, I'm supposed to get 180. So if I'm given one, I'm supposed to obtain the other one. That is why you see on that information that I gave you on the triangle, I refer to a triangle with an angle of 120 degrees, which is an obtuse angle. But on the given information, they won't give you corresponding information for cos 120 or for sine 120. No, they are going to give you the values for sine 60 degrees. You'll be wondering, why am I given the value for sine 60, the value for cos 60? What is it that happened here? They are simply taking to say, if this is an obtuse angle, its corresponding acute angle is supposed to be what? If I am given an angle here of 120 degrees, it's on a straight line with what is going to be this angle here. We simply subtract 180 degrees minus 120. We obtain what? 60 degrees, which is our acute angle. So the 60 degrees is the one that is our acute angle. And here we have the obtuse angle. So if I am given 60 degrees in the given information, I'm supposed to relate it back to 120 because that is its corresponding obtuse angle. So what I'm simply saying is that if you are given, let's say you are given an angle of 70 degrees, what is going to be the corresponding obtuse angle? The obtuse angle is going to be 180 minus 70 degrees, which is going to give us 110 degrees in this case. So meaning to say, on the diagram, they are going to give you a triangle, whatever information, with an angle of 110 degrees. But you are supposed to take it back now to the given information. On the given information, they are going to give you the value for sine 70. They are going to give you the value for cos 70. They are going to give you the value for tan 70. They won't give you the value for this information. Why? These two, they share something in common. What is it that they share in common? That is our question now. In terms of our obtuse angle, in our syllabus, we do not work with the whole of this quadrant, but it was taken actually from this quadrant of all students take calculus. So in our syllabus, I'm going to explain these two quadrants, this one, the first one and the second one. These ones, they are not important, but you consider them in your A level, so forth. All right. In this quadrant, we are simply saying these angles are taken as 0, 90, 180 degrees, whereby we are saying from 0 degrees up to 90 degrees, this is an acute angle. All these angles here, we are talking about in between, any angle that is in between, not at 0, not at 90, but in between, they are going to be representing our acute angles. Greater than 90, but less than 180, we are going to be talking about the obtuse angles in this case. Remember from our definition of the obtuse angle. So it follows that for these angles that we refer from 0 to 90, that we say these are our acute angles, they are all positive. This A here is for all, meaning to say all acute angles, all acute, all acute. What we are saying here, the ratio, not for the acute, but all ratios, let's consider this way, all ratios that we consider. Which ratios are we talking about? We are talking about the ratio of sine theta. We are talking about the ratio of cos theta. We are talking about the ratio of tan theta. All these ratios, they are positive. So the sign that is here that we see, it's positive. If we move on to this quadrant, it's for S, meaning to say it's sine, which is positive. If we move here, it's tan, which is positive. If we move here, it's cos, which is positive. But like I said, in our syllabus, we're going to consider these two quadrants because that is where we are talking about what an obtuse angle concept in this part. If you consider this part, that is where we talk about the obtuse concept, whereby they are on a straight line. So you talk about acute angles and the ones that are greater than the obtuse angle. So for the obtuse angles, which are the ones that are greater than 90, but less than 180, it's only sine which is positive. So what does it mean? It means cos, it's a negative, tan, it's a negative. So if you understand this, it simply means for all given obtuse angles that you have, you are going to consider the trigonometrical ratios for them, which is the corresponding trig ratio. It must be a negative. But it's a negative of which value? It's not just like a negative. It's a negative from the acute angle of this first quadrant. So what I simply mean is that since here we are talking about the sine, which is representing an obtuse angle. So we are going to say the sine of the obtuse angle is going to be minus, because, sorry, it's going to be a positive. We said sine is a positive. So it's going to be positive sine of the acute angle in this case that you are given. So here we're talking about the obtuse angle, here we're talking about the acute angle. But when it comes to cos, if we talk about the cosine of the obtuse angle, the cosine of the obtuse angle in this case, it is going to carry a negative. We are talking about an obtuse angle, it must be a negative. So it must be a negative of the cosine of its corresponding acute angle. Guys, we must understand this concept. Cos, it's a negative. Tan also is a negative. So the tan of the obtuse angle, the tan of the obtuse angle must be equal to minus tan of the acute angle. All right, let me explain it this way. If we are referring to this part that we said before, remember what I said here. I said, if you are given, or in paper 1, they will give you a diagram that has got a triangle. In this case, you'll be given a triangle with an angle of 110. You are given these two sides, whatever that you have. On the given information, they are going to give you information not for 110. They are going to give you the information of the corresponding angle, which is the acute angle. 110 is an obtuse angle, it's greater than 90. So from 180 to 180 minus 110 like this, we are going to obtain 70 degrees. So this 70 degrees is the one that is representing our acute angle in this case. This is our acute angle. And we are talking about 110 being what? Being the obtuse angle. This is our obtuse angle in this case, the one that is greater than 90 but less than 180. So what I'm simply saying, on the given information, they are going to give you the value, not for this one, for 110. They will give you information about 7. They'll give you sine 70. They'll give you the value. They'll give you the value for cos 70. They'll give you the value for tan 70. This is what they're going to do. Depending with what you are going to do with the information, I don't know, you're going to use the cosine rule or the sine rule, but wherever you are going to want the value for sine 110, or the value for cos 110, or the value for tan 110, there is no way you are going to obtain this because you're in paper 1, you do not have a calculator. So what is it that you are supposed to relate from 110 to these angles that you are given here? How are you going to relate it? This is our obtuse angle, just like this part. And the 70 degrees is the corresponding acute angle. So you simply use this information that I said, that for the obtuse angle, it's only sine, only sine, which is positive. It's only sine that is positive. So it means the sine of 110 degrees, which is our obtuse angle, is equal to the positive sine of the acute angle. And what is the acute angle? The acute angle there, it's 70 degrees. So it simply means you are going to take the value of sine as it is, you multiply with a positive. So it's going to remain as a positive. If you move on to cos 110 this time, cos obtuse angle, 110 is our obtuse angle, is equal to minus, because cos is a negative for obtuse angle. It's only sine that is, we need to say cos and tan, they are negative. So cos is going to be a negative of the cos acute angle. What is the acute angle there? It's cos 70. So we take the value for cos 70, you multiply it by negative. That is the case. The same thing with tan. Tan is also a negative. So you take the value for the acute angle for tan, you multiply it. What is the acute of 110? The acute there, it's 70. You multiply that value by a negative. Okay, let us take this into consideration by proving this on our calculator so that we understand this part together. I want you to see that this is it's a relationship that was actually proven. It's not like we are saying that something that is not mathematical. Let us have the value for sine 10, sine 110. This is sine 110. I want you to get the value. It's 0.939. All right, this is sine 110. And we are saying sine 110 is equal to plus sine 70. All right. So if I take the value for sine 70, I multiply it with a plus, it means I'm not even affecting, because a plus does not even affect. So sine 70, look at the value, 0.939. Same value like the value for sine 110. We are obtaining the same answer. If we take the value for cos 110, this is cos 110. I want you to see the value for cos 110. Cos 110, it's an obtuse angle, this one. Look at the value, minus, it is already giving us a negative. This is to show you any value for cos, as long cos it's an obtuse angle, it gives you a negative. That's negative 0.342. But if you check cos 70, because cos 70 it's an acute angle, it is supposed to be what? A positive. We said all acute angles, they are positive, all the ratios. So cos 70 like this, it is supposed to give us a positive value, this because it's an acute angle. But as you can see, it has the same decimal place, 0.342. So we are saying from this part, for us to obtain cos 70, to obtain cos 110, from cos 70, because we saw that cos 110 is carrying a negative. So in order for us to obtain cos 110 from cos 70, because cos 70 is a positive, what is going to happen? We are going to multiply by a negative. The moment we multiply this by a negative here, the moment we put a negative here, look at the answer, minus 0.342, it's giving us exactly the value for cos 110, exactly the value that we got, the same decimal place as it is. That is why we are saying these two, they are equal. You see that is going to be the same for tan in that manner. So using this information, that the obtuse, for all the obtuse angles that we are going to be considering, it's only sine that is going to remain as a positive. We are going to be relating to questions of this nature. Before I go back to my right angle triangle, I actually wanted to just focus on a right angle triangle, but now it leads me to this stage. I want to answer this part before we move on to our right angle triangle. All right, so this is what is going to happen here. They will give you a triangle ABC. Given triangle ABC, you're also given angle ABC, which is 120 degrees. Then you are given this side 5 centimeters, then this other side given as 6 centimeters. Then you are asked to calculate BC. All right, calculate AC, calculate AC in this case. You are in paper 1, take note, you are considering paper 1 where you do not have a calculator. So like I said, these guys, what are they going to do? They are going to give you values, not for the angle that you are given here, not for this one. No, they will never do that. That one is going to be a bonus package if they do that. So they will give you the value for sine 60. They will give you information like this. Sine 60 is equal to 0,866. That is what they are going to do. They move on to cos 60. They do the same thing. Cos 60 degrees is equal to 0,500. They just round off their values to 3 decimal places, depending with the degree of accuracy for that particular question paper. They will give you the value for tan 60 again, which is 1,732, like this. This is what they are going to do. All right. You are asked to use as much of the given information. They will actually write that statement. Use as much of the given information. Use as much. And this is the given information. This is the one that you are given. That's your given information. So how are you going to play around with the given information to calculate AC? All right, the formula that you're going to use, that one is your choice. It's up to you, because we talked about the sine rule, the cosine rule, and so forth. So we're not going to talk about that. Please make sure that you watch the videos on solving triangles so that you learn about the rules and so forth. But if you consider here, we are going to apply the cosine rule since we are given two angles, two sides, and an included angle. This one is referred to as an included angle. So meaning to say, if we are given an included angle, we are going to use the cosine rule. So remember, cosine rule, how does it state? The cosine rule states that a squared is equal to b squared plus c squared minus 2bc, the cosine of a. So this one, as you can see, there is an angle at b and a, but I consider to say the part that is a squared is the one that you're calculating. So a is the one that you're calculating, which is AC. I want you to see what was going to happen. You're going to substitute information. AC squared is equal to this side squared, which is 6 squared plus 5 squared minus 2 times this side again, the a, the b and c, which is going to be 6 times 5. Yes, you can name your order the one that you want, but B and C, these are the sides that you're given. That is what it means. This A is the side that you're calculating. This A is the angle that you're given, the included angle, and our angle there is 120. So we're supposed to write cos 120 like this. This is what we're supposed to write as. All right. You are in paper 1, guys, remember, where you do not have a calculator and there is no way for you to obtain this value for cos 120 here. So what are you going to do from this given information? That is where now we go back to this part where we consider what happens between an obtuse angle to its acute angle. We said for any obtuse angle that you are given, it's only sine, which is a positive, according to the quadrant that we are referring to. That's why we're talking about obtuse angle, obtuse, only for obtuse angles, and that is the only part for our syllabus. When you get to A level, we shall be talking about something else. So don't say it's gonna be like this, or A level we shall be talking about something else. So here we are only talking about these two, obtuse and acute. So what are we given? We are given the obtuse angle on our triangle here, but on the information, we are given the information about acute angles. These are acute angles that we are given here. And if we relate properly, remember what I said about the acute angle and the obtuse angle, they are found on a straight line. So if I subtract 180 degrees minus this 120 here, I'm going to obtain 60 degrees, which is exactly the corresponding acute angles that we are given, 60, 60. So for cos, it's going to be a negative because it's only sine which is positive. So cos is going to be negative of the cos of the acute angle. So meaning to say, for us to obtain the value for cos 120 in this case, for you to obtain the value of this cos 120 that we see here, we are simply saying cos 120 degrees is equal to what? 120, this is our obtuse angle. It must be equal to minus cos of the acute angle. The acute, this one is the obtuse angle. So it must be equal to minus cos of the acute angle. So this is the one that we need here, our acute angle. And what is our acute angle from 120? The acute angle is 60 degrees. And so meaning to say, we are going to multiply cos 60 degrees, the value that we see here, by a negative. We obtain the value for cos 120, meaning to say it's going to be minus times cos 60. Our cos 60 is minus 0, all right, these zeros after the comma are just for a presentation to say our digits our values, they are to 3 decimal places, but on calculations, there's no need for us to write this. So it's going to be minus, it's going to be minus times 0.5, which is going to give us minus 0.5. So meaning to say, wherever there is cos 120 degrees, wherever we see cos 120, wherever we see cos 120, we are going to use minus 0.5 from the acute angle. Let's check with our calculator if this is true. To say that, is it true that cos 120 is it minus 0.5? This is our calculator here, cos 120 degrees. If you check, we obtain exactly minus 0.5. If we check cos 60 degrees, this is where we have the 0.5. So we just multiplied 0.5 times a negative, we got minus for cos 120, which is exactly the value for cos 120. So meaning to say, we are using exactly the value for cos 120, but we simply took this value from its acute angle. That is the relationship that you need to know. That is the only relationship that you need to know. If you understand this relationship, you can answer any question that you be given, as long you are given the obtuse angle and they give you information on the acute angle. This is how you relate the information. So with this information, we are simply going to substitute where there is a cos 120 here. We are going to substitute its value now, which is minus 0.5. So it means here, we can simplify this as AC squared is equal to, so you can just simplify 6 squared, that is 36, plus 5 squared, which is 25, minus 2 times 5, that is 10, times 6, which is going to be 60. Is that so? That is going to be 60 there. All right, then cos 120, we are saying we are multiplying the whole of this cos 120 is what? It's minus 0.5. So we are going to multiply by minus 0.5. So meaning to say, AC squared is going to give us, once we add 36 and 25 together, we are going to obtain 61 minus. So take note on this part here, you are in paper 1. BODMAS also applies. Here you combine these two, but here we are supposed to multiply. Remember, from our BODMAS concept, we've got a multiplication there. So we are supposed to multiply by 0.5. So it's a negative versus a negative, which is going to give us a positive. We multiply 60 by 0.5. 0.5 is the same as half. So we are simply saying half of 60. Half of 60 is what? Is 30. So there's no need for us to multiply 0.5 times 6, simply half of. So we are simply adding there. So AC squared is going to be, we add these two, that is going to give us 91 in this case. Then we introduce the square root both sides to remove the square. We are going to introduce the square root both sides. So that means remember we are in paper 1. So therefore our AC is going to be the square root of 91. That is a condition whereby you'll be given, leave your answer in said form. So meaning to say, we are going to obtain this as a square root of 91. That is in what? In said form. Remember, you are in paper 1, you do not have a calculator. And they are giving you these values of 120, and also the simplification, you can't simplify because you're in paper 1. So you leave your answer in set form, and they will definitely ask you to leave your answer in set form on a consideration like this. This is how you relate. This is how you relate an obtuse angle and an acute angle. Cos becomes a negative, tan a negative. So you simply multiply the value that you are given of the acute angle for the cos, you multiply it by the negative. That is what happens. So from the same question, they might even ask us to calculate the area. Let's say we were being asked this time to calculate the area of this triangle. All right, this time we want the area of the triangle. They are asking us to calculate area of triangle ABC. It's a non-right angle triangle, and the only option that we have for the area is to use for the formula. Area is equal to half AB sine of theta, whereby theta is the angle that we are given, which is the included angle. So we're going to have half of the sides A and B, which is any of this part. So we're going to have half of 6 times 5 times the sine of theta, which is the sine of 120 degrees. We are back again to the limitation now of our paper 1. We do not have a calculator, and we need the value for sine 120. What is 120 representing? That's an obtuse angle. What are we given? We are given acute angle. So what is the relationship between sine 120 and its corresponding acute angle? Remember, for all obtuse angles, it's only sine which is a positive. So meaning to say the sine of 120 degrees is going to be the positive of sine 60 degrees, which is our acute angle. And we are given this. So it's just going to remain as a positive because we're already having this as a positive, which is going to be 0.66. So that is going to be the value of sine 120 in this case, meaning to say in place of sine 120, this is the value that we are going to use. So meaning to say we are going to substitute. So our area is going to be half of 6 times 5 times the sine of 120. The whole of this sine 120 is now represented by what? 0.866. That is how they ask these questions, just like that. So you can simplify further. In this case, you can multiply here. That is going to be a 3. 3 times 5, which is 15. So therefore, our area, you're going to multiply. We multiplied 3 and 5. We got a 15. So you're left with 0.866 times 15. So there you're supposed to multiply properly this part. All right, let me just do it. Since we're in paper 1, there's no way. Let me just do it. So you're going to have 0.866 times 15. All right, so 0 is a placeholder. 1 multiplies everything. 1 by 6, that's 6. 6, 8. 5 by 6, that's a 30. 5 by 6, that's a 30 again. We add this 3, so that's going to be 33. 5 by 8, that's a 40 plus 3, which is going to be a 43. Okay, that's here we're going to obtain a 0, a 9, a 9, then a 12. All right, 4 plus 8, that's a 12. Our main decimal places from the first place, we are given 3 decimal places from the 0.866, this one. We've got 3 decimal places. We're going to count 1, 2, 3. So our comma is going to be here. So meaning to say we are going to obtain 12.99, which is in square centimeters. So we have determined the area from the sine 120 without a calculator using its corresponding value, which is the acute angle. So you just need to know this relationship, meaning to say if it was a consideration, maybe there's something that needs us to use tan. Tan also, remember tan is a negative also, so it's going to be minus tan 60 degrees. You simply take the value of tan 60. Tan 60 is what? 1.732. You multiply by a negative. That is the value for tan 120. So that is how you use the given information to calculate for any angle that you be given, depending with which angle that you're going to use, which ratio, I mean, is it the ratio for sine? Is it the ratio for cos? It depends. So I think I've mentioned both for cos, for sine. Yes, we can have for tan. In other cases, it depends. All right, so I want us to go back to our normal right angle triangle and apply this in conclusion. Now we want to apply this on a normal right angle triangle. There it was a consideration whereby they will give you a non-right angle triangle in paper 1. Also in our paper 1, they are going to give us a right angled triangle. But on that right angle triangle, they want us to have information between obtuse and acute angle. All right, so the first thing that we are going to consider is that we are back on our right angled triangle. So what we are going to discuss here are 2 things. First, we're going to discuss 2 things about our right angled triangle. Remember, I said on your right angle triangle, you'll be given a certain angle, which is theta. All right. Talking of a right angled triangle in this case, there is no way that we are going to have an obtuse angle inside a right angled triangle. There is no way, because I want us to consider this. If this angle is 90 degrees, what does it mean is that we are remaining out of 180, because our angles in a triangle, they add up to 180. So if we subtract 180 degrees minus 90 degrees, which is our right angle, this one, we remain with 90 degrees. Meaning to say these 2 angles here that we have here, they share this 90 degrees. They both share that 90 degrees. So meaning to say, If this is 30 degrees, this is going to be 60 degrees. If this is 40 degrees, this is going to be 50. These two angles, they are going to share the remaining 90 degrees. So it's impossible for us to have an obtuse angle inside a right angle triangle, because we are saying an obtuse angle, remember, it's an angle that is greater than 90 degrees but less than 180. So if our obtuse angle is greater than, and we are saying these two angles must share 90 degrees, it means it's impossible for us to obtain an obtuse angle here. So the theta that we see here inside a right angle triangle, it represents an acute angle. So this theta, that's an acute angle. It represents an acute angle. Why? Our acute angle is an angle greater than 0 but less than 90. So definitely this angle must be less than 90 because they are adding up to 90. Both, they must add up to 90. So it means it's less than 90. So if we find an acute angle inside a triangle, what about the one that is going to be here if we extend or if we produce this line? Because we now have a straight line, we have extended this line, so we now have a straight line. The moment we have a straight line, we are going back to that relationship that I discussed before. What is the relationship that we see on a straight line? On a straight line, it follows that these two angles, they lie on a straight line. This is what I mentioned here. An obtuse angle and an acute angle, they are found on a straight line. Before we talk about the ratios, these two, they are found on a straight line. So it means if we are saying this is an acute angle that is inside of our right angle triangle, it means the remaining angle here is going to be an obtuse angle. Okay, let me extend here. Let me extend here so that you see me proper here. The remaining angle, this one that we see inside, outside of the shape, this one becomes our obtuse angle because they both are on a straight line. So this becomes our obtuse angle. That is the relationship. So meaning to say, if we are to relate back to those ratios that we talked about before, we said for all obtuse angles, it's only sine which is this part does not lie, even if we are talking about a non-right angle triangle. As long it's an obtuse angle, only sine here is a positive. So only sine, it's a positive. Only the ratio of sine. So only sine is what is positive. That is the idea. The only sine is positive. So the idea here does not change because we are on a right angle triangle. No, only sine is going to be a positive in this case. Let me present this so that you'll be with me. Only sine is going to be what? Is going to be positive. So what am I trying to say is that if only sine is positive, it means back to our trigonometrical ratios, because the moment we talk about a right angle triangle, we think of the trigonometrical ratios. So we are going back to say the sine of the obtuse angle is going to be the positive of the sine of the acute angle, which is the ratio of the acute angle that is inside here. If we are talking about cos, the cosine of the obtuse angle is going to be negative cos of the acute angle that is inside the triangle here. The same thing with the tan of the obtuse angle. It is going to be equal to minus tan of the acute angle. Remember our relationship. This part does not change. So some of us, we are confused about this part here to say if this angle is referred to as theta, then they will ask you to find the value of cos 180 minus theta or whatever that you are given in this case, because remember, this is just a straight line. So if this angle is theta, it means this angle outside here is going to be 180 minus theta. According to this, if this is theta, then the one outside is going to be 180. From which concept? If this angle is 50, how do you determine this one? You subtract this angle from 180. So it's going to be 180 minus 50. So it does not say whenever you see 180 minus theta, it means you are dealing with an obtuse angle. No. They can give you theta outside of the diagram like this. This is where you have your theta here. This part does not change to say theta is outside of the diagram, so it changes to be acute angle. No, that part does not change. It's still an obtuse angle, this one. It's outside of the triangle. The one that is inside is our acute angle, which is now 180 minus theta. So it does not mean to say 180 minus theta is always an obtuse angle. No, you relate to say, where is theta? Is theta outside or not? Is 180 minus theta inside of the shape or outside of the shape? If it is outside, then it's an obtuse angle. If it is inside, then it's an acute angle. So this is the basic part that you're supposed to understand from your 180 minus theta and theta concept. All right, so let me go back to this part that I was explaining about the obtuse angle and the acute angle, where we said these two, they are related from the basic ratios that we are taking, that we are given. Like for question, let us consider question number 1 for our clarity. On question number 1, we are given that if A is obtuse, take note. If A is obtuse, they are telling us that A is obtuse. A is representing an obtuse angle, and sine A is equal to. All right, if you are given sine, they have to specify that that sine is a positive. They have to specify that sine is an acute or it's an obtuse. Why? Because sine is positive both for acute and both for obtuse. So meaning to say, when you are dealing with the ratio for sine, they must specify that it's an obtuse angle. So they are saying this A that we are talking about, it's an obtuse angle. So what does it mean? On our diagram, we are going to have a sketch here. This is our triangle. All right. So we are going to have our sketch. The moment we are talking about obtuse, it means we are extending the line. So this is a right angle triangle. So the A that we are given here is not inside, because we cannot have an obtuse angle inside. Always inside the triangle, the angle that we have there is what? It's an acute angle. So meaning to say A being obtuse is this one that is outside of the shape, this one, that is our A. That is the obtuse angle that we have. And the one that is inside here is going to be what? If this one outside of the shape, what about the one inside? We subtract from 180. So this one inside the shape is going to be 180 degrees minus A. So that's 180 degrees minus A in this case. All right. So what they are going to do is that they are going to give us the ratio for sine A. All right. Which is 3/5. We are given the ratio for sine A, and we need to find the ratio for what? For cos. All right. This is what we are given. I want you to understand. You understand me properly. All right. This one. Let's just remove this page. All right. So we are given the value for sine of A, which is 3/5. And there they want us to find the value of cos A, the value of tan A in this case. All right. This is what we are given. This A here, it's an obtuse angle. This one, we are told that it's an obtuse angle. So what you do is you relate it back, because as long as I'm talking about an obtuse angle, it is related back to the cosine of the acute angle. Remember, here we're talking about A being acute angle, all right? The acute angle here and the obtuse angle being our O in this case. So I was saying, from the ratio of cos, it gives us the cos of the obtuse. From the ratio of the sine acute, it gives us the ratio of the sine obtuse. So this part does not change. So meaning to say, you are given the information, yes, about the obtuse angle, this one. But what you do is that you relate this information back to the acute angle. So you are going to relate this back to the acute angle. Relate back to the acute angle in this case. All right. So we are going to relate back to the acute angle. All right. So if we are relating this back to the acute angle, what does it mean? We are simply saying the ratio does not change. The ratio of sine of theta, which is the sine that is inside of our triangle, which is our acute angle in this case. This is the one that is inside the triangle, which is our acute angle. The ratio of its sine does not change, which is the ratio of sine 180 minus A. This one is just a ratio, it's like an angle, it's just an angle. Don't be worried to say I'm going to multiply by sine. No, you are not multiplying, it just represents an angle, just like 10 degrees, just like 20 degrees, just like 30. So you are given its ratio here, which is 3/5. This is what you are given. So meaning to say, from this ratio, we know that it's taken from a right angle triangle, whereby we know from our soccer tower that we explained before. What does it mean? it means sine is opposite over the hypotenuse. So here I'm given the value of the opposite over the hypotenuse. In this case, I have opposite and the hypotenuse at the same time. So I can relate it back to say, okay, this is my acute angle inside of the triangle. What is the opposite there? The opposite is this side, the one that is facing my angle, the acute angle. You relate to the one that is inside. And what is our hypotenuse? Our hypotenuse is the longest side, which is this one. So from your Pythagoras theorem, you are going to use now your Pythagoras theorem to calculate the third side. All right, we are back to our h squared is equal to a squared plus b squared. You substitute 5 squared is equal to 3 squared plus b squared. We calculate this side. So 25, 3 squared, that is 9, plus b squared, transpose this 25. Minus 9 is equal to b squared. So that will be 16 is equal to b squared, the square root both sides. So meaning to say our b is going to give us a 4. It was supposed to be plus or minus, but we take the positive value. So meaning to say here, we have a 4, maybe 4 centimeters, 4 meters, whatever that you are given there. You have this side. All right. So our question is to calculate or to find these ratios. We have filled in from the information that I'm given here. I've managed to fill in my diagram. Now with this diagram, I want to find the ratio for cos A, which is cos A is going to be what? The ratio is not going to change, guys. The ratio for cos does not change from our SOHCAHTOA concept. All right, let me write it back, our SOHCAHTOA concept, so that you do not miss me on this part. So here we are going to relate back. The ratio does not even change. And from our SOHCAHTOA concept, like I was saying here, we are going to refer back to our SOHCAHTOA concept. In this case, this part does not even change. The cos being adjacent over the hypotenuse, but this time we are saying this A that we are relating, it's an obtuse angle. So it is going to be minus, because we are saying the cos of the obtuse angle is equal to minus the cos of the acute angle. The adjacent over hypotenuse is taken from the ratio of cos, which is the cosine of the acute angle, the one that is inside. So our answer is going to carry a negative. So meaning to say the cosine of A was going to be minus adjacent over hypotenuse. What is the adjacent? According to the angle that is inside. So we have got our opposite here, our adjacent, and our hypotenuse. So our adjacent there, that is a 4 over the hypotenuse, which is going to be a 5. That is how you answer this question. The same thing if we move on to the tan that we are given. The tan there that we are given, A is an obtuse angle. So meaning to say tan obtuse is equal to minus tan of the acute angle. So we are going to multiply the tan with the negative, because you are talking about the acute angle, but you are calculating the obtuse angle. You are calculating the ratio of tan of the obtuse angle. So it's going to be a minus. So we are going to have opposite over adjacent, opposite, which is 3, over adjacent, which is 4. But our answer carrying a negative, because these angles that we are relating, they are obtuse angles. So their ratios, they must be negative. Cos must be a negative. Tan must be a negative. That is how you play around with this ratio. That is how you play around with this information. So you see that you'll be given typical questions, all this part. So if you check now for cos before I talk about this question, let us just consider for cos in this case. And for tan and for cos, what are they going to do? They will actually specify like this part, tan, this is a negative. Why are they specifying that tan B is a negative? I mean, why are they not specifying later on to say B is obtuse? They gave us that tan B in this case, or number 2, tan of B is equal to negative 24 over 7. They have already told us here, this angle B, we must know that this B represents what? Because under tan, for it to be a negative, it means this B is representing an obtuse angle. Remember what I said, guys, about obtuse angles. Only sine is positive, cos it's negative, tan is also a negative. Remember, for acute angles, we cannot have an acute angle carrying a negative. No, all acute angles, they are positive. So the moment you are given a negative here, it shows you that this angle B, it is an obtuse angle. So on your diagram now, in order for you to answer the remaining of this question, you are going to just have a sketch. So this one is just a sketch. You're going to have a sketch in this case, knowing that I've got an obtuse angle. So this B that we are given is this angle, the one that is outside of the shape. Remember what I said, the obtuse is the one outside of the shape. The one that is inside of the shape, this one is our acute angle. This is our acute angle. And all acute angles are all ratios which correspond to acute angles. They are all positive. So meaning to say, you are going to refer back to the ratio of tan of the acute angle to say from the tan of my acute angle, in this case, this is the acute angle that I'm talking about, which is going to be 180 minus B. If I want, I'm going to write this as 180 minus B. Its ratio is supposed to be given from our SOHCAHTOA concept, that's opposite over adjacent in this case, whereby this is what I'm having, 24/7, not the negative. The negative is there to show us that B, the obtuse, is the one that is that we are relating to. But the acute angle is always a positive. We take this is the ratio that we want, 24/7. So it means according to this opposite over adjacent, according to this angle here, our opposite is this one. This is our 24. This is our adjacent 7. So meaning to say you are supposed to calculate the hypotenuse, which is our third side in this case. So from which concept? How are we going to calculate the hypotenuse? That is where we go back to our Pythagoras theorem again. H squared is equal to A squared plus B squared, where hypotenuse squared is equal to 24 squared plus 7 squared. So you're going to have 24 squared plus 7 squared, whereby H is equal to 24 squared. That is going to be 250, 557. This one is 576, and plus 7 squared, which is 49. Then we add these two together, you're going to have 625. So this will be H squared is equal to 625. The square root both sides. So H is going to give us a 25. So meaning to say this side here is 25. Having our hypotenuse now, we can answer the questions which follow, like this part where we are being asked to find or to calculate sine of B and the cosine of B. How are we going to have these ones? We ask ourselves, B, which B are we talking about? The obtuse angle, the one that is outside of our shape. This is our obtuse angle. So meaning to say, sine, is it affected? Sine is not. Remember we said for all obtuse angles, only sine is positive. So sine is not going to be affected. The sine of B, which is representing our obtuse angle, this one, that is our obtuse angle, is going to be equal to plus the sine of the acute angle in this case, which is we are referring to the sine of the acute angle. The acute angle in this case, sine is a positive, does not affect. So if it is not affected, it means the sine of B is going to be what? The sine of B is going to be plus the opposite. Now we are back, all right, sine from our SOHCAHTOA, all right, SOHCAHTOA. So that is a sine opposite over hypotenuse. So the sine there is going to be, according to this angle, what is the opposite is 24 over the hypotenuse, which is what, 25, but as a positive now. So meaning to say our sine B is going to remain as positive. All right. We move on to the other value that we are given, which is the cosine of B. From this part that we are talking about, what is going to be the value for cos B in this case? B, it's an obtuse angle. And for obtuse angles, only sine is positive. All right, this is 25 here, not 24, 25. All right, so for the obtuse angles, we said only sine is positive. Cos is what? Cos is a negative. So meaning to say our cos here is going to be a negative. So we're going to carry a negative because B represents an obtuse angle. So it's going to be negative of what? Of the cos inside the angle, which is the one that we take from what? Adjacent over hypotenuse. So it's going to be minus adjacent according to this angle here inside. This is our adjacent. Remember, this is our opposite. This is according to this angle, the one that are on a straight line. So our adjacent there, that's a 7, hypotenuse, that's 25. That's it. That's you have the corresponding value for cos B. So that's how they are going to be playing around you guys, this and that, you're done. So it's the same thing, even if you check on our diagram here, they might even just give us information direct. Like if you check, we are just given in fig 11.1, PQR is a straight line. All right, so given that this is a straight line, and this is where we have our angle theta. Find sine theta, cos theta. So you just check, all right, this is the theta. What does it indicate? Is this acute or obtuse? This is obtuse because the acute is the one that is inside. This is our acute angle here. All right. So, all right, sorry for that. Just hope you're gonna be able to finish here, guys. So this is our acute angle. It's because this video is too long now. All right, this is our obtuse angle, the one that is outside of the shape. That's our obtuse angle. Greater than 90, less than 180. Greater than 0, less than 90. Acute can only be inside of the triangle, like I explained. So here they want you to find the value for sine theta, which is the obtuse angle. That is our obtuse angle. Theta does not mean the angle is acute. No. Theta represents the angle. So check where the angle is. Theta can be inside of the shape, can be outside of the shape. What matters is where it is located. Where is your theta located? Is it inside or outside? If it is outside of our triangle, it's obtuse. Inside, it's acute. So meaning to say, here we are asked to calculate the sine of an obtuse angle, this theta representing an obtuse angle. And what happens with sine? Sine does not change. Remember, I said for all obtuse angles, sine remains a positive. So remember the ratio again from our SOHCAHTOA concept, sine is opposite over hypotenuse. So it's going to be opposite over hypotenuse in this case, but being a plus. So our opposite, according to the acute angle inside, what is the opposite? It's 5. What is the hypotenuse there? That is a 13. Remember, according to this angle here, this is our opposite, this is our adjacent, and that is our hypotenuse. So sine is going to remain as a positive. What about cos? The cosine of theta. For obtuse angles, cos becomes a negative, tan a negative. Only sine is opposite. Only sine is a positive. So cos is a negative of what? Adjacent over hypotenuse. That's it. So it's gonna get a negative. So meaning to say negative of adjacent, which is 12, over the hypotenuse, which is 13. The same thing, if they asked us for tan, we're going to have the same answer here, the same concept. Tan theta, tan is it's a negative because we're talking about theta being what? Being an opposite, being an obtuse angle. So that is going to be negative opposite over the adjacent. So we are going to fill in minus our opposite there, which is 5, over the adjacent, which is 12. So that's how we answer these questions. So they will give us a direct consideration that this is an obtuse angle, or this is that. You simply need to work with match questions for your practice. Or sometimes they might mention according to this inequality concept. They will give you a certain consideration. The sine of theta is equal to 4 over 5, given that theta is greater than, or given that theta is greater than 0 degrees, but less than 90 degrees. Find, you are now asked to find the cosine of theta, the tan of theta, the sine of 180 degrees minus theta, the tan of 180 degrees minus theta, the cosine of 180 degrees minus theta from the given information, this one, even this. All right. So the first thing is, we are told that the theta that we are referring to is an angle that is greater than 90 degrees, but greater than 0, but less than 90. What does it mean? We are simply talking about an acute angle. This theta they are giving us here, it's an acute angle. Like I said, for sine, they are supposed to mention, because you'll be confused to say, which theta am I talking about? Because sine is positive always. For all the acute angles, we said all the trigonometrical ratios for all acute angles, they are positive. But if we go to the obtuse angles, that is where we consider negative angles, and only sine there it's a positive. So that's why sine they have to specify, because you won't be able to tell whether it's acute or it's obtuse. So they are going to specify that this. So here it simply tells us that this sine is an acute angle. So if it is an acute angle, I'm going to have my diagram like this. This is what you're going to do. You draw your diagram, all right? Just a right angle triangle extended. So meaning to say, according to this right angle triangle, theta being an acute angle cannot be outside here. Theta cannot be outside this time, like what we saw on this diagram here, whereby theta was outside of the diagram. If you consider here, that was an obtuse angle. The acute angle, it's inside. So if we are given that our theta is greater than 0 degrees but less than 90, it means we're talking about acute, and the acute cannot be outside. The acute is going to be inside. So the theta that we are given this time is the one that is inside. If they gave us a condition that this theta here is greater than 90 degrees but less than 180, it was another story. We are considering something else. The theta now is this one. If they give it this way, this was going to be your theta, an obtuse angle now. But here we are told that our theta is less than 90. So meaning to say your theta is the one that is inside of the shape. So from this part, you're going to obtain, remember, from your SOHCAHTOA concept, that part does not change. SOHCAHTOA. All right. So sine, that's opposite over hypotenuse. So here you are given the ratio of opposite over hypotenuse. According to this, theta, that is our opposite. This is our adjacent. This is our hypotenuse. So we are given the opposite in this case, according to theta. This is our opposite, which is 4, and our hypotenuse here, which is 5. So I'm not going to waste much time. We talked about using Pythagoras theorem to calculate the third side. So if you use it properly, this side is going to be a 3. All right, this is what you have on your diagram. The information on your diagram is this. But if you check later extended, we are seeing angles like 180 minus theta, 180 minus theta. What does it mean? I said 180 minus theta simply means the angle that is being on a straight line with the theta. Our angles on a straight line add up to 180. So by subtracting, they are simply giving us this angle that is outside. If this angle inside is 30 degrees, how do you calculate the angle outside? You subtract it from 180. So if this angle is theta, it means the one outside of our shape is going to be referred to as what? As 180 degrees minus theta. There's nothing they are mentioning here. It does not mean that 180 minus theta represents an acute angle or an obtuse angle. It represents the other angle from what you are given. If this is theta, 180 minus theta is the one that will be outside. So in this case, it means we're talking about 180 minus theta representing what? Representing the obtuse angle. In this case that we have here, in this case, if we consider this case, it's another scenario, it's another story. Let us talk about this case so that we properly understand each other here. We were given here theta as the obtuse angle. The acute angle is the one that is inside, meaning to say this angle inside from this theta that we are given, it is the one that is going to be 180 minus theta, this one inside. So in this case, 180 minus theta is indicating the acute angle, theta indicating the obtuse angle. So where the angle is located, that is how you play around. Where is it located, that angle? That is what tells you, is it obtuse or acute? It's not about theta or 180 minus theta. No, where is it located? So like we said, theta here is representing what? An acute angle. So we are talking about theta being an acute angle, 180 minus theta being an obtuse angle. That is what you're given. So our questions is find the first one, cos of theta. So how are we going to obtain the cos of theta? You ask yourself first, what is this theta representing? Theta is the one that is inside. So we're talking about the theta of an acute angle. And what is it that we know about acute angles? I mentioned from that part, all students take calculus, and we said for all acute angles, all ratios here, they are positive. All ratios, all, it's for A, all ratios are positive. As long it's an acute angle, it will be positive. So cos theta, because it's an acute angle, it is going to remain as a positive. So that is going to be positive of what? Our ratio adjacent over hypotenuse. So according to our ratio, adjacent is going to be 3. The hypotenuse is going to be a 5 in this case. So that is how we take our info. So that's considering this part, you're going to have even any ratio that you be given. What is important is that, guys, you are supposed to know the relationship between the angles between acute, obtuse. So our cos there, because it's representing theta and our theta is acute, according to our diagram here, it becomes a positive. So that is what you're going to have here. What about tan theta? We are also representing theta being acute, and for all acute angles, they are going to be positive. So this one is going to be positive of opposite over the adjacent in this case. So the opposite according to this angle, that is 4, over the adjacent, which is going to be a 3. All right, let us consider these ones now where they are saying sine 180 minus theta. What is it that we are going to have on sine 180 degrees minus theta? We say it. This one simply represents another angle. So if this is acute, 180 minus theta, it's an obtuse angle. So what is the relationship that we know between the obtuse angle, because this one is an obtuse, related to its acute angle inside of our shape? We said sine is positive, sine acute, sine obtuse, sine is positive. So meaning to say this one is going to remain as a positive of the sine inside, which is opposite over hypotenuse. So it's going to be opposite over hypotenuse, which is going to remain as the 4/5 that we had, carrying a positive. So this one is just going to remain as a positive. Then the same thing with the tan of 180 degrees minus theta, we relate back to say 180 minus theta, according to our diagram, it's an obtuse angle. And for all obtuse angles, we know that only sine is positive. So tan is going to carry a negative. Tan and cos, they carry a negative for obtuse angles. So it's negative of what? The tan ratio, opposite over adjacent, does not change. So it's going to be minus 4/3. The same thing with our cos. The cos 180 degrees minus theta, we relate it back. It's an obtuse angle. And cos, it's negative. So it's negative of its ratio adjacent over hypotenuse, which is going to be negative of 3/5. So that is what you're going to see between the acute angles and their corresponding obtuse angles. The fractions here are the same, but only that for obtuse angles, cos is going to carry a negative, tan is going to carry a negative. So the 180 minus theta, like I mentioned, it's not about the angle to say it's obtuse or acute. It's from the diagram. Where is it located? From where it is located, that is where you can tell, all right, this is my obtuse, this is my acute. If it was given, let me conclude in this way. If we were given an information, and from that information, you have drawn your triangle like this. This is what you have from your information, and this is your theta. I explained it before, and this one becomes 180 minus theta. So it means, according to this information, this is now our acute. The 180 minus theta is representing the acute angle. This theta is the obtuse angle. So what you're going to see that is that the sine of theta, which is the obtuse angle, is going to remain as a positive. The cosine of theta is going to be a negative because we're talking about obtuse angle. The tan of theta is going to be a negative because we're talking about obtuse angle. But for all these ones that are inside the triangle, which is the acute angles, all acute angles, they are positive. So sine 180 minus theta is going to be a positive. Cos 180 minus theta is going to be also a positive. The same with tan 180 degrees minus theta. It is going to be a positive according to our presentation to say this is theta, this is 180 minus theta. We are not talking about quadrants to say from us to no, we are talking about the relationship of angles. In our syllabus, they want you to relate angles. How are they related? from acute to obtuse. So theta here, we're talking about theta being obtuse. From 180 minus theta, we're talking about this being acute. But if you check from that previous diagram that we had, from our previous diagram that we had a condition like this. We had a condition like this, whereby the theta was inside of the diagram. From our right angle triangle, this was your theta. This became 180 degrees minus theta. You subtract from what you're given, the other one will be 180 minus. If this is theta, what is inside is 180. If this is theta, what is outside will be 180 minus theta. According to this diagram now that we have, this angle inside, it's our acute. This part does not change. The angle always inside our triangle is our acute. So theta is now representing the acute angle in this case. So theta is now representing acute. The obtuse represented by what? By 180 minus theta. 180 minus theta is now representing obtuse. So meaning to say this time it's not going to be sine theta positive, cos theta negative. It's going to change because theta is now an acute angle. So sine theta is going to be positive. Our sine theta, our cos theta is also going to be positive. Our tan theta is also going to be positive. Why? We are referring to acute angles in this case. Acute angles, all acute angles are positive. So this one is going to be positive. It's ratio for cos, it's ratio for tan. But the moment we move to 180 minus theta, which is now representing an obtuse angle, it means the sine of 180 degrees minus theta, this one is not going to change. Remember, sine is always positive. But cos now is going to change. Cos 180 minus theta, because we are now talking about theta being what? Being obtuse. Being an obtuse angle. So the cos there is going to carry a negative. As we saw for all obtuse angles, cos is a negative, tan also a negative. So the tan there of 180 degrees minus theta is going to be also a negative. So what you are supposed to keep in mind is the relationship between acute and obtuse. Theta and its corresponding angle, which is 180 minus theta. If theta is obtuse, 180 minus theta is acute. If theta is acute, 180 minus theta is obtuse. Not to say wherever you see theta, you say theta is an acute angle. No, that one is something else. You have to relate it when we are now talking about our A-level mathematics. That's where this part will be constant. It does not have this mix of confusion like what they did in our syllabus. They have a mix of confusion because we are relating back to a triangle. We are not talking about it back on a normal quadrant, how it's supposed to be like. We are relating back to our relationship between the two, the obtuse and the acute. So we shall see more questions as we revise, but let's just check questions like November 2009, paper 1, 2010, June 2010, or it must be June 2010 or June 2008, paper 1, where we have got specific questions that are related to what I'm explaining right now. And some of the questions that are recently being asked, they are actually asking this part. So let's revise that part so that if there are questions, we come back with them so that we can work them together. But for the basic introduction, this is what we need, guys. Let's continue to revise as much as we can.